Hello everyone, my name is Shiga and welcome back to this part series that we're working on. Right now, today, we're going to be focusing on implicitly unwrapped optionals. Apologies if you hear some background sounds. I'm at home and I like it. Okay, cool. So let's see what's going on here. So that's pretty much what we're going to be talking about today, implicitly unwrapped optionals. And, as I was looking at this, I had a lot of questions in my mind. For example, some words such as implicit, obviously unwrapped, and optionals, because we can see we're taking three words here and we're putting them together to make a statement. So pretty much I wanted to understand what the word implicit means. Implicit meaning, did I spell it correctly? Okay, so the word implicit stands for implied, inferred, hinted, suggested, implied. Okay, as I think about this, I'm thinking about pointer references in C++. I don't know if this is the same thing or not, but I remember in C++ you could we had this concept of pointer reference where different variables can share the same memory location. So I don't know if it talks about the same thing here. So we also touched about optionals, I think, in the previous video, optional binding, and I'll just read here quickly about what an optional is. We learn here that you use optionals to find out whether an optional contains a value. Okay, it starts from optionals first. Okay, cool. Here's optionals here. You use optionals in situations where a value may be absent. This is when you use an optional. An optional represents two possibilities. Either there is a value and you can unwrap the optional to access that value, or there isn't a value at all. Remember, in the previous video, we also covered this word unwrap here and tried to really figure out what the word unwrap means. What did we get into about it? Okay, cool. I don't remember. Let's continue. But I remember we covered the word unwrapping. I think the previous video explains it very clear there what we're talking about. Unwrapping optional. So here it's pretty much the same thing, but now the only difference is the word implicit. So pretty much I think we're gonna learn the same thing about unwrapping optionals, but then with the new keyword here that is added, which is implicit, and we're gonna see what it means. As described above, optionals indicate, okay, I'm reading here. Let's start by reading here. As described above, optionals indicate that a constant or variable is allowed to have no value. Optionals can be checked with an if statement to see if a value exists. So now, if optionals are not allowed to have a value, what is the value that is stored in optionals? Is it a null value? That's the one that comes to my mind. Let us test this out. So I'll say var, let's see here, because we know the syntax to writing an optional. Okay, cool. We have a question mark here. So let's say var is this optional. I don't know why I had to say that. And then I'll put a string, and then I'll just leave it like that. And it should accept this to work, because what we do know is that if I say var, this is not an optional, and then I just do a string, it won't take anything. The compiler will complain because this is not an optional. That's one of the things that we do know about this. Is this is an optional. Okay, why is the compiler not complaining? Let's say print okay. As we can see here, we just declared a variable, but then we're not able to use it because it's not an optional. Like we talked about it, it's not an optional. Let's see what the error says. It says variable used before being declared. So now with an optional, we can use a variable before it is declared. That's one of the things that we see about it. But then when we do not have an optional, we cannot use this variable before it is declared. That's what we see about it here. This is not an optional, used before, oh, not declared, initialized. I was looking for that word. Initialized. In other words, there's no value assigned to this variable. Initialized. Cool. We cannot use this variable before it is initialized. That makes sense. But then here, if I say this is an optional, we should be able to use this variable, as you can see. So that means whenever we declare something as an optional, it assigns it as a nil to begin with. So then if this is the case, if I then do this, does it mean that I made this thing into a nil? Let's see something. Nil cannot initialize specified type string, add question mark to perform type. Okay, cool. Okay, cool. I see. So then without this optional inference, or without this optional, I don't know what to call it, without this question mark here, which indicates that this variable is an optional, we cannot assign it a nil. And that's what we see here. And I think this is very, very impressive, as we see here. But then now that also means whenever we do this, by default, the compiler is going to assign this variable a nil. As we can see, when we display this variable, we get a nil. But then here, we are not able to assign this variable a nil. So now the question that comes to my mind is, what is the definition of a nil? I hope I won't take this out of context, but then that's the one thing that I wish I could just understand about the definition of a nil. Okay, let's see as we continue here. Where were we? Sometimes it's clear.
Oh, that's a what's it? 15. 4. 15.
Sure.
Right, too much.
Iranda mule Filipino. Sure.
But it's a change.
Okay, sorry for that. So we learned that sometimes it's clear from a program structure that an optional will always have a value. Okay, from the program structure that an optional will always have a value after that value is first set. In these cases, it's useful to remove the need to check and unwrap the optional's value every time it's accessed, because it cannot be safely assumed to have a value all of the time. Okay, let's look at this clearly here. So sometimes it's clear from a program structure that an optional will always have a value. Okay, I understand what this means here. For example, we do know that with a constant variable, it will always have a value, because a constant cannot be empty, or a constant cannot be nil. Let us try to prove it and see if this is the truth there. Let this is a constant, right? Can't just say string, just like I did here, and then say print this is a constant. The compiler should not agree to have this be. Okay. This is used before being initialized. Alright, cool. Let's see now. So does this mean that I can have an empty, but then it won't work either way? And if I say this is a constant, is equal to 30, we know this shouldn't work as well, because we cannot assign, oh, sorry. This shouldn't work as well because we shouldn't be able to reassign a constant a different value. This is a constant is equal to 40. Okay, so I guess I see now what's going on here. So we can declare the constant, but we can only initialize the constant once. In other words, we can only assign the value to a constant once, and that's it. But then that means my previous statement that a constant can always have a value is incorrect, because we see we can declare a variable, a constant, and not have it have a value. So now can we declare an optional constant then? That's very interesting, because I'm trying to think of the logic, or in other words, the semantics behind this. Also far, the compiler is happy with this because it's an optional. I think pretty much the optional allows us to have a nil, honestly, when I think about it. Allows us to have a nil, honestly, as I think about it, because now this constant here has a value, and the value is nil. That's what we can tell about it. If I say print this is a constant, I'm going to get something like nil. Okay, let's see. This is a constant used before being initialized. Now that's interesting. Okay, this is interesting because we see with this as an optional, we're able to create an empty variable which has the value of nil, as we saw here. Where's the value of nil? Okay, I'll just bring this back up a bit. Let me just do this. Cool. And just only run from this point here. So we do see that this is a nil inside of it. That's what we do see. But then with this constant, it appears that we cannot have it contain a nil as we declare it, or by default it doesn't contain a nil. Let's see how it looks. Rather, it complains. It says, no, we cannot have this be. It's a violation of some sort. Constant, this is a constant used before being initialized. Now, it's quite interesting how we were able to pretty much do the same here, and it worked here. But then when we get to constants, this rule or logic does not apply to constants. I think what this means is that probably we do not, or rather I do not fully understand the concept, or what is this, the logic behind, I'll just call it concept right now, the concept behind constants, right? And pretty much how they're defined by Swift. So cool, let's see. But then what we do know about a constant, obviously, is that we can assign it a value, but then we can only initialize it once. Cool. Just like we can print this is a constant. And then if we print this out, cool, we're able to see. But then it says, hi there, this, that's what it pretty much says. I think this is where if I remember correctly, this is where unwrapping comes in. Because here we're displaying the optional and not the value within here. So I'm imagining something like an onion, right? An onion has layers in it, and you want to print the innermost layer of the onion, which is hi there. But then currently what we're doing, we're printing the whole onion. So now we need to peel this down. I think that's where unwrapping comes in. Let me confirm this quickly. I think this is where unwrapping comes in, because we want to print the innermost, what is this? The innermost value within the optional. Let's see. Forced and unforced unwrapping. We talked about it. I remember we talked. optional binding. We talked about unwrapping before. Okay, so that's where we use this exclamation mark here. I think it's the exclamation mark. For example, if I now do this, I've just unwrapped, because before it is wrapped here, we are displaying the whole onion as I made an example of it. But then now whenever we do this, as we add this optional, what is this, this exclamation mark, now we're unwrapping, we go into the innermost layer of the onion, just like we can see here. And now we're displaying hi there. That's what we're supposed to print right now. We're supposed to print only hi there. So now we've unwrapped this optional. Okay, I remember now. This is quite interesting how I almost forgot that for a second. Let's see as we continue with this. Okay, implicitly unwrapped optionals. Okay, I'm worried that I might drift out of topic and things like that, but anyway, let's come back. I'm gonna read this again. Sometimes it's clear from a program structure that an optional will always have a value, and I think I made the mistake here by saying, what is this? A constant will always have a value. Well, that is true. It will always have a value because by, what is this? The rule states that you cannot use an empty constant. You can declare constant. You can only initialize it once. You cannot initialize it more than once. But even if you've declared the constant, you cannot use it anywhere else on any other expression. For example, let's just do this. Let this is a number, and then I'll just make it a number, right? And just leave it. Oh, integer. I think it's an integer. Cool. I'll just make this an integer, and obviously it's empty inside. I cannot then print an expression. Okay, cool. Over this is the sum, and then I'll say 1 plus this is a number. Now this makes sense obviously because a number is empty. We don't know what's in here at this point. And what's interesting is I'm not even sure if this is a nil or what, so we don't know what's inside this thing. So the compiler will refuse. So I think this is the rule that I was mentioning here, that some variables need to have, some constants need to have variables, and you cannot use them if they're not initialized. I think that's a simple rule between everything else, really. You cannot use a variable or a constant that is not initialized. You can declare it, but you cannot use it if it's not initialized. Cool. Okay, the declare it was a very high pitch, but I liked it. In this case, it's useful to remove the need to check and unwrap the optional's value every time it is accessed, because it can be safely assumed that it can be safely assumed to have a value all of the time. Because it can be safely assumed to have a value all of the time. In these cases, it is useful to remove the need to check and unwrap the optional's value every time it's accessed. Okay, I need to understand what they mean by that, because what I see here is that sometimes we check if an optional is unwrapped. We need to check and unwrap the optional, and we know that when we unwrap the optional, we use an exclamation point, which is here. That's what we see here. So far, that's what I understand. So maybe let's continue and it'll make sense for us. These kinds of optionals are defined as implicitly unwrapped optionals. Okay, implicitly unwrapped optionals. Okay, cool. So then we were able to see that sometimes when we print an optional, just like in this case here, where was this? Okay, cool. When we try to print this optional, it was wrapped, right? We can see it's an optional and it is wrapped. And another thing that comes to my mind is an optional, an array. If I create another optional, is this something like optionals here? Print. And I just do this optional and I say 0. Will this work? I do not know. Okay. Because I was thinking probably stored within an array or something, but okay, now it makes sense. Generic wrapped could not be inferred. Explicitly specify the generic argument to fix this issue. There's no number. Okay, we see there's something about an optional. Pretty much an optional is an object. And whenever we declare something, I think we're storing it somewhere inside an optional. That's what I'm seeing here. You write an implicitly unwrapped optional by placing an exclamation point rather than a question mark. Okay, cool. This here allows us to have a nil, right? But also, this is going to give us a wrapped optional. That's what we do see here compared to an unwrapped optional. So if I say let, this is an unwrapped optional. Okay, I should even use the implicitly unwrapped optional. This is an implicitly unwrapped optional. Okay, that's too long, but it's fine. Now remember, I just made this into, oh, it's a variable. No, it's a constant rather. Let me just do a var. It's a constant. So now what happens when I do this here? Okay, and then cool. Here we declared the implicitly unwrapped optional. So now let us initialize it. So we're gonna say this is an implicitly unwrapped optional is equal to I'm cool, guys. Cool. And then we're just gonna print this is an implicitly unwrapped optional. So now let's see what's gonna happen here. Cool. It says I'm cool, guys. That's what we do see here. But it's still wrapped because let's see this. It's still wrapped. It's only unwrapped as I add this exclamation mark here. What are we learning here? You write an implicitly unwrapped optional by placing an exclamation point rather than a question mark after the type that you want to make optional. Rather than placing an exclamation point after the optional's name when you use it, you place an exclamation point. Okay, let me zoom in a bit so that we can all see. I forgot to zoom in. But I also need to make sure. Ooh. Alright, cool, it's fine. Rather than placing an exclamation point after the optional's name when you use it, you place an exclamation point after the optional's type when you declare it. So now what is the difference here? What exactly are we trying to achieve? That's the one that comes to my mind, because in the code, it all appears that they are the same thing. When I try to display it, it shows me the wrapped optional. And then when I do it this way, it shows me the unwrapped optional. I think that one thing that comes to my mind here is that what if I'm on an if statement? And then obviously we do know that it appears after. If not, and let's say this thing holds it true or false, then I'm gonna have something like this is a constant. Okay, let's do this. Okay, let's say let is true, then I'm gonna make it a boolean. I'm gonna make it a boolean value, and then I'm gonna make it an optional, and then I'm gonna leave it like this, and then I'm gonna say is true, and then I'm gonna assign it to true, and then cannot convert type bool to what? Okay, is true. Then if I want to make an if statement, I know if is true, which will yield to true. If is false, true, not true, is false. So now print true. So now, according to this, then it means I'm gonna have another something like this. I don't know if this is what it means here, because obviously, let's try to print this first and see. Print is true, and then I do this. We can see here it has an optional true, so it is wrapped. And so now the question is, does this also affect my if statement? Because now we do know that our if statement looks something along these lines. We have if not optional true, and then obviously the statement here. That's what I know we do have if we remove this. So now will this yield true? Okay, it should be true here. Let's begin with that. Should be true. That's what I do see. Oh, now it makes sense, because if we see this carefully, it says, oh, it is wrapped. And because it is wrapped, this is what the if statement sees. It sees optional true. I think this is where now it comes in. So now what we're learning here is that they created a way of making sure that we don't have to constantly unwrap it whenever we want to use it, because now I'm gonna have to do something like this and then false. Obviously here I'm trying to write what is this, and a statement of some sort. For example, this is a logical statement. If is true and false. If it's true and true, then it should do something like that. I don't know if it makes sense, but then now here, obviously, it gives us a funny problem. Let's see what the problem is. Missing white space between. Okay, cool. Okay. I'm sorry. So, ooh, Matlala. What happened now? Oh, okay. I think I see what could be the issue. Okay, cool. So if true and okay, now it works. But then now obviously I can see how this can somewhat be a bit confusing to a lot of people. So now I think this is what we call implicitly unwrapped optionals, so that they do not, so that the if statement doesn't see this, and yet we don't even have to write this exclamation point here. So let us see the syntax to fixing this problem. Implicitly unwrapped optionals are used when an optional's value is confirmed to exist. Immediately after the optional is first defined and can definitely be assumed to exist at every point thereafter. The primary use of explicitly unwrapped optionals in Swift is during class initialization, as described in an old reference, sys and implicitly unwrapped optionals. But then why doesn't it want to work here? An implicitly unwrapped optional is a normal optional behind the scene, but can also be used like a non-optional value without the need to unwrap the optional value each time it's accessed. The following example shows the difference in behavior between an optional string and an implicitly unwrapped optional string when accessing their wrapped values in an explicit string. Okay, let's see. You can think of an implicitly unwrapped optional as giving permission for the optional to be forced unwrapped if needed. If you use an implicitly unwrapped optional value, Swift first tries to use it as an ordinary optional value if it can be used as an optional. If it can't be used as an optional, Swift forces the value. If Swift unwraps the value, force unwraps the value in the code above, the optional value assumed string is forced unwrapped before assigning its value to implicit. Okay, I see now. So then that means in order for us to get this to work, because we said this is bool. Okay, no, but then no, I did it wrong either way. It was supposed to be this way instead of that way. So now Swift should force unwrap this optional here. Let's see if we're gonna get what we need. Okay, cool. So it's not complaining. As we can see, because we declared it this way, Swift no longer sees this. It only sees true because it is forced unwrapped. And I like this. It makes sense to me right now. Let's print this and see. Okay, no, let me remove this. Since it's true, obviously we should see false. We should see true. We should print true somewhere here. Cool. So then that means even if I do this, print is true, I should only see true and not the wrapped thingy. Okay. Well, it's when it comes to print, it's still wrapped. So then that means I need to unwrap it. So now what I'm seeing here is obviously that when it comes to here, we didn't have to unwrap it. Swift force. Wait, I'm looking for the term that they used here. Swift forced unwrapped the value for us. That's what I'm saying. Swift forced unwrapped the value for us. In the code above, the optional value assumed string is forced unwrapped before assigning its value to implicit string, because implicit string has an explicit non-optional type string. In code below, optional string doesn't have an explicit type, so it's an ordinary optional. Okay, cool. If an implicit unwrapped optional is nil and you try to access its wrapped value, you'll get a runtime error. The result is exactly the same as if you place an exclamation point after a normal optional that doesn't contain a value. Okay, this makes sense. We tried it and we saw it's true about it. You can check whether an implicit unwrapped optional is nil the same way you check normal optionals. Cool. You can also use an implicitly unwrapped optional with optional binding to check and unwrap its value in a single statement. You can also use an implicitly unwrapped optional with optional binding to check if an unwrapped value is a single statement. Don't use implicitly unwrapped optionals when there's a possibility of a variable becoming nil at a later point. Always use a normal optional type if you need to check for a nil value during the lifetime of a variable. Okay, I think I see this. All right, cool. I think we were able to do some good stuff here. I think we got to learn something important about optionals, and I'm going to end the video here. Thanks, guys. We'll keep in touch.